Hi everyone, we're going to pick up with 11.9 now with doing power series, taking those power series and using them to represent certain functions. And so certain things like trig functions or rational functions can be approximated or represented by a power series of possibly something like a polynomial. And so that's what we're going to be looking at in this section. So you might remember this little idea that your summation from n to starting at 0 to infinity of x to the n was the same thing as the uh, polynomial 1 plus x squared plus x cubed, that series that we talked about maybe a section or two ago. And so that actually is 1 over 1 minus x. It's you can get that value from being a geometric series. And so we know what it sums up to be. And so I could come up with an approximation for 1 over 1 minus x using this long string of polynomials added together. The actual graph for the 1 over 1 minus x would be this kind of purplish line, and that there's a reddish pinkish line at y equals 1, where that would be the first term of my polynomial. So that first term, didn't mean to do that. That first term, this 1 right here is this line. But if I was to bump it up and say what happens when n equals 1, well, that straight line becomes 1 plus x, or x plus 1. You get a linear line that goes like this. Each one of these lines would be an approximation. So here we're centered at 0, and so if I was right at plugging in 0, then I would actually end up being exactly the approximation, the exact value of 1 over 1 minus x. But if you get too far off of that, if you get to x equals 1, 2, 3, the approximation gets worse. So what we can do is we can make this longer. Maybe we go out to the third term and make it an x squared. So we'll get a parabola like this. That parabola gives you a little bit better approximation because you're getting more overlap in this area right here. And so we could probably go out to 0.25 either way and get a fairly good approximation. Or if you wanted to go even further, what if you wanted to go out to a cubic? Well, you get a graph that looks like this. And notice now we're getting even more overlap. And the further you go out, the more you'll get of approximation, especially wherever it's centered at. So if you're centering at 0, you're going to get a really good approximation for your 1 over 1 minus x around the number x equals 0. If you went out to infinity, though, they would actually start overlapping at 0 all the way across, which is really nice. So if you went out another one, for instance, you get this kind of graph, and then now you're getting a whole bunch of overlap all the way up this direction. So that is what we can do, and we can get an approximation for a value right at wherever it's centered at. So what we would like to do is find a power series representation for these type functions. So we're going to do ones at the moment where these are ones that I could probably, have no problem plugging values in. It works out better if you're doing things like trig functions. What's the sine of 5 degrees? Well, that's kind of hard to do. But 1 over 1 plus x squared is not terribly hard to do. We do want to keep in mind that the one we're working with here is really that one series, your summation from n equals 0 to infinity of x to the n is 1 over 1 minus x. So what I'm going to do is try to replace this 1 over 1 plus x squared and try to rewrite it to make it look like 1 over 1 minus x. And then I would come up with my power series representation. And so let's just replace the x with negative x squared. Because technically this is the same thing as 1 over 1 minus negative x squared. That would be the same thing. And so whatever's sitting right here would match with whatever's sitting right here, and this matches with that x right there. So I'm going to rewrite this as the summation from n equals 0 to infinity. And I replace the x to the n with negative x squared to the n. Or if you want to make it look a little nicer or try to simplify it, it doesn't really matter. You could leave it just like that if you wanted to. But the negative to the n would be no different than negative 1 to the n. And then the x squared to the n would be x to the 2n. So you could rewrite it like that if you like. This would be your power series representation right here. And if you wanted to continue that on and kind of pull off a few values, see what they look like, you would end up with a positive 1 to begin with if you plugged in 0 for the n's. Then you'll notice you don't get an x to the first power because the x has a 2n on it. So you'll actually get a minus x squared, and then a positive x to the fourth, and a negative x to the sixth, then a positive x to the eighth, and so on. So you're getting that sort of thing going on all the way across. So you're getting all the even powers for your x's, which kind of makes sense if you're looking at 1 over 1 plus x squared, starting at 0 or higher, you're only going to end up with positive values. So your polynomial has to give you basically positive values on your powers. Hopefully that makes sense. We'll do another one kind of like that. So 1 over x plus 2. Starting with that same series, we'll end up with 1. Oh, sorry. I'm going to write down the original series first. This x to the n is 1 over 1 minus x. So I need to rewrite this to look like 1 over 1 minus x instead of 1 over x plus 2. So I got to have a 1 on the bottom, not a 2. So one thing I could do is I could divide everything in the problem by 2. And the 1/2 can just come out in front, the 1/2 that's on the top. And I'll end up with 2 over 2 is just 1. And then I'll end up with an x over 2. And it's starting to look a little bit more like my 1 over 1 minus x. Now I have 1 over 1 plus x over 2. But I can do a little bit more adjusting, kind of like what we did on the last one. I could do 1 over 1 minus negative x over 2. And then I have 1 over 1 minus something, just like I have 1 over 1 minus something on the other one. So whatever's sitting right here matches with this x, and whatever's sitting there gets an n put on. So my series, there is a 1/2 in front, so don't get the 1/2. The 1/2 just gets factored out front, so just coming along for the ride. And so I'll get negative x over 2 to the n. Again, you can adjust this a little bit if you'd like. From the fact of the negative to the n would be no different than negative 1 to the n. It's just making it alternate. Then I'll have an x to the n on top and a 2 to the n on the bottom. And the reason why I'm splitting that up is because technically the 1/2 out in front could then come back in and combine with the 2 on the bottom. And I could say my series looks like negative 1 to the n, x to the n, and then I have a 2 to the n plus 1, the plus 1 from the 1/2 that gets factored out front. I can pull it back in, and it would look something like that. And I won't worry about plugging numbers in here, but if you could plug numbers in if you wanted to. Your first one would just be 1/2, and then your next one would keep going up in powers. Okay, this one's probably a little bit harder, just because you might look at it as x cubed over x plus 2, but really it's the same problem we just did. It is the exact same problem with an x cubed on top. So this is x cubed times 1 over x plus 2. So instead of going through the whole process again, what you could do is say, well, I already know what the power series representation for the 1 over x plus 2 was. I just wrote it down. So this is x cubed times the summation of n equals 0 to infinity of negative 1 to the n, x to the n, over 2 to the n plus 1. That's from the previous example. And since I just have an x cubed multiplied by that, I could pull this x cubed in, kind of like I did with the 1/2 on the last one, and make this be the summation of n equals 0 to infinity of negative 1 to the n, x to now the n plus 3, over 2 to the n plus 1. And this would be your power series representation for x cubed over x plus 2. So hopefully that's not too bad. That's a kind of a short idea. We're gonna take this sort of idea and compound it with what's coming up in the next section. But you could really do. There's a whole list of different ones that you could manipulate. I just picked the 1 over 1 minus x to be the one that we manipulated, but we can manipulate a whole bunch of them. And I'll show you a list coming up. So hopefully that's not too bad. And we're going to jump into 11, 10, and 11, 11 next.